Now we see that we recapitulate a little bit. Here's our original system. We eliminated C and we obtained this system, and then we eliminated B and we ended up with A approximately equal to 0.00226. We now take that value of A and substitute it back in to the first equation in our system of two equations. We're going to put the 0.00226 in here for A. And you see over here we're going to get 2379 times A, which is 0.00226. And then we'll move over a little bit and see that we have plus our 39B, from the 39B over here, equals negative 30 from the negative 30 over here. So everything in the equation on this side appears here except that A has been changed to 0.00226. Well, we multiply this out, we get 5.37. Our 39B comes down, our negative 30 comes down. Subtract 5.37 from both sides, we get negative 35.37 equal to 39B. If we divide both sides by 39, we end up with B equals negative 0.907. Excuse the scratch outs here. Occasionally we have a little typo with our handwriting. If you can have a typo with handwriting. Now, at this point we've got values for A and B, so we circle those in purple and indicate that we bring those values up to the first of our original three equations. We could have used the second or the third equally well, but we chose the first. And when we plug in, let's look at that again. Okay, we circle the values of A and B in purple and bring those up into the first of the original three equations. Again, we could have used the second or the third equally well. But when we do that, we get an equation where we substitute for A and B. And that equation looks like this. 121 times 0.00226, 11 times negative 0.907 plus C equals 80. And without going into any detail, that's easy to solve. We multiply these, subtract from both sides, multiply these, and also subtract that from both sides, and we end up with C in a very straightforward calculation. So now we've got values for A, B, and C. We come back down here and take a look. Okay, we see that A is 0.00226, B is negative 0.907, C is 89.7, and that gives us our mathematical model. Because remember, we started with y equals AT squared plus BT plus C. And what do we have here? Well, we have y equals AT squared plus BT plus C for the A, B, and C that we've calculated for this problem. This is therefore our mathematical model for the depth of the flow versus time.